Well, hello friends. Today we're going to work on using the JSON stuff for something, and I thought we would use it for the proc file system. So I'll show you something in the proc file system right now. So if we go to /proc, we can look at something like summary, for instance. Well, it's kind of a stupid one because that one is already pre-printed. It's one of the first things that I did. So let's look at instead all. Right, so here's a comma separated value file with all the processes in the system. And this format is very clunky, and it would be cool if we could use JSON instead. And then this file is then opened by things like the process manager and the top program and even this little guy up here. So we need to teach all of those how to read JSON from this file instead. But I think that generally this is a good idea, so let's try it out. So I guess we'll start in the kernel by making the JSON output. So that would be in a function called procfs all. This is where the output is created. So let's see, I can zoom a little bit. So we're going to want to do something a little bit different than what we're currently doing here, obviously. So we'll do something like a JSON object. We're going to need to include these actually. JSON, I guess value, and let's just get the whole shebang. Okay. So that would be the outermost object. So what we're going to do at the end here is we're going to return object.serialized to byte buffer. Okay. And build process line, or instead we're going to say like, we can just rename this to build process, whatever. Okay. And then we will say, it's weird that this is process star, actually, so let's make that into a const process amp. There we go, it's a little nicer. Of course, now we need to fix these, but we gotta fix them anyway, so each process is going to be a JSON object in itself. And let's see, process object set PID. I mean, we should just do these. So let's see. Times schedule. TTY. Oh, okay, hold on. It's like a little bit difficult to see what these things even are. But it would be a lot, it's going to be a lot easier to work with this file after we've done this. So we got the UID, the GID, and JSON objects are not in any order, so it doesn't really matter what order we do these, which is one of the main benefits and good reasons to do this. That it's no longer going to matter what order the things are. Like with this format, it really matters what order things are, and you have to be cautious when you're putting something in there. Let's see, state to string process state. I mean, yeah, PID. PID. can just call it an FDS actually. Name. TTY. Let's not forget about the TTY. TTY name. Oh, wait, hold on. What am I doing? Either that or no TTY. Then process object set. Amount virtual. This is not the most exciting stuff I'm doing here, but we're almost at the end, so just bear with me. Shared. It's main thread ticks and main thread time scheduled are a bit weird. Because it would be good to do all threads, but right now we only do the main thread. That's fix me. Of course, it will be easier to add threads to this format once we move to JSON, because then you can just have a thread object that's inside of this object, and instead of it was not really obvious how to do that with the old format. Anyway, let's keep going. So ticks is main thread dot ticks priority process priority. I guess to string. That's weird. We should probably just have the number here, but right now it doesn't matter. Syscall and syscalls. Oh, let's call it syscall count. Okay. That's it. Boom. And then all we have to do is to add this to the adder object. So we can do something like object.set. And I guess we can just use the PID. So we'll do something like process.pid. What am I trying to do here? Process object. There we go. Variable object cannot be implicitly captured. Well, I'm sorry. How about we capture everything then? Okay. Right, so now we just create this object and then populate the whole thing with that. So I think if we build this, okay, well, we got to fix some stuff first. So we don't have any conversion from size t. So we're going to need JSON value helper for that. Let's just add one. Signed. We'll do the same to this guy right here. So actually, we can even just say JSON value. Right now, this works. Although maybe they should be the other way around, actually, because then if we switch things over to using 64-bit at some point, then this will do the kind of the reasonable thing. Unsigned size t. Redefinition of JSON value. They are the same. Well, why do you believe that they are the same, friend? I mean, I know that they're the same size, but they're supposed to be different types. Size type. maybe we should do this here instead. I feel like getting the decal type of size of void star should be the same thing as this. Maybe it's not. Okay, well, we're gonna need to just add some ACK objects here because we are also pulling in the JSON stuff. So JSON value and JSON array. Okay. JSON value in 32 max. Where does that come from? You know, we can just do that. And we don't have to worry about libc headers and ACK right now, which I don't love. Oh shit, I did not think of this. Floating point numbers in the kernel code. Well, clearly we can't do that. We can't do floating point in the kernel because we don't want to have the kernel worry about walking all over the floating point unit state, because in the Intel CPUs, when you do task switching, then the floating point stuff is not included in the context switch. You have to do that manually. So we don't want to clobber FPU state in the kernel, because then that would mean that the kernel has to first save the FPU state whenever it wants to do something, and then restore it, which is a very heavy operation. So instead we just decide not to do any FPU stuff in the kernel. And that's why I'm getting told here. So let's see. So I'm gonna need the parser, it seems like. And oh, this is not good. Shit. Well, I guess we can have like a variant of JSON value that just does not work for floats in the kernel. So floats are just disallowed, or it's disallowed in the kernel. So let's see how we do this. First off, we can just get rid of that one then. Unsigned. And we'll just only have size T, that's fine. But for this guy, we'll do like if and def kernel. So we're not going to do that. And if so, let's see. It's not defined kernel. Well, let's just say if def kernel return keyword and value as int, because that's the only thing that we're gonna have, and not end of it else. Okay, here we go. And if def kernel. I feel like I'm stepping into some kind of error-prone territory here, but let's just stick with it and see what we can come up with. Okay. Well, we'll just skip all over these things. JSON value. Okay. So double. I'll say if def kernel m type is type int. So the problem now is that we want to we want to store the unsigned value so that we somehow know that it's bigger than the maximum signed int. I suppose we could just have an unsigned int type. And we wouldn't hurt so much from the lack of the double. Okay, so let's see, we can do that. Okay, as you int, or m type is type unsigned int. Wonder if we're gonna be okay with this. We'll see. We'll see. So in this case, it's always going to be unsigned int, actually. And then we'll say value as you int is value. All right. And then we'll just build these out. Oops. Okay, so I think that's all of those. And then let's just go look in the JSON parser. Do we have any doubles? I didn't even implement double parsing yet. So it's not the end of the world. Parse number to int. Well, we're gonna need a bigger int here, so let's see, if not okay. Or actually, we can start with int parse. If not okay. Yeah, all right. Cool. Now we're getting a little farther. So, or are we actually? Conversion from unsigned int to JSON value is ambiguous. So is this called count? It's an unsigned. And what if we do that? Then size t is ambiguous. Great. Well, how about we just do both then? I don't know why QCreator is complaining about this. Constructor cannot be redeclared. Well, I hear you. Can I placate you like that? And then we can just put unsigned. All right, double is not. Now we're getting somewhere. JSON value. Right, we need to hide that here. If m type is type int or return true. If def kernel. Okay. Well, that got a lot hairier than I was hoping. So let's see what this looks like now. Well, beautiful. We had a big blob of JSON. The process monitor up here is just going crazy because he does not recognize the format. But we are getting the format, so let's see. Obviously this thing is not going to work very well, but let's implement it. So that will be in the process model. That's the data model that drives the process manager application table view. And there is some parsing code here in process model update. So what that currently does is that it opens the proc all file and then reads it line by line and then like parses the comma separated values. So what we're going to do instead is we're going to read all file contents. Okay, and then we'll say JSON value, I guess, is the one that we need. JSON value for auto JSON is JSON value from string file contents to, oh, how do you do that? String copy? Oh, well, that's very ugly. I wish I wouldn't have to copy the byte buffer just to get to the data. Makes me, it's gross that we have to copy the byte buffer to create a string for parse. Is JSON value from string not taking it? Oh, it's taking a string view actually, so we don't have to do that. We can just string view of the file contents dot data size. Is that cool? Yeah, that's cool. Okay. And then we don't need to do this in a loop actually. We can just do it like this. And then let's see, end of old loop, just so that I remember what I was doing. Okay, so then we don't need to break here. And if the file is empty, then that is weird. So we can just keep going actually. Okay, then because, well, why is that trying to break up the loop? Because we're going to want to be in a loop anyway. Just we're not going to loop over the lines. We're going to loop over the JSON values. So we'll put those outside the loop. Okay, and then JSON value. Object. Didn't we have some for each member? Yeah. JSON as object for each member. Okay, we're getting there. I haven't been using this code much though. Let's see, name and auto value. And not comma here. Okay. Now this should be a matter of doing value dot get. Well, we'll say auto process is we'll call it process object actually, because that matches what we did in the kernel. Value as object and it's a JSON object just for the clarity here. So get PID to oh, we don't have a conversion function for that. JSON value. Well, we have 2D word. We could just use 2D word right now, actually, that's fine. PID is an int, but negative PIDs are not valid, so this is okay right now. Let's just try to make progress. So let's say process object get. Oh man, I'm gonna have to bring up the procfs because I don't remember what I called all these things. Times scheduled. Huh. Okay. Okay. Priority. To string. Count. I'm not sure that this is the best API for the JSON object. It's just the one that we have right now, so we're gonna make do with it. But I really find that going through this process of using an API, that's how you discover what the API should really be. So stay with a string. So like for instance, I'm already getting the feeling that it would be good if these things, if I didn't have to do the type conversion here, but like that they would just slot into the this process state object the way that they are. Somehow, I don't know. We'll figure it out. Name to string. Mount virtual to the word. Physical. Let's get physical. Okay. Did we get everything? Well, we don't need that. Oh god, what is this code? Right, we need to exit this loop down here. Or exit this lambda, rather. Okay, so there's a low chance of this working, I would say. Auto name, it's unused. I'm not using it. And name is the frickin' PID. But I guess I don't care about the PID because I have the PID in the field too, so I'm just gonna grab it from the field. Will this work at all? Nah. Assertion failed as object. Okay, well, you don't like that. I'm calling as object somewhere, I'm sure, and it doesn't like it. So let's see. Let's then just print out the serialized JSON here. Debug printf. We can do, what are some non-JSON characters? Damn it, let's do these. Trip me up there. JSON serialized characters. Okay. Sync and run. process manager. Okay, so we got all the JSON out. So let's actually slap this into one of those JSON validators or viewers. It was on stack.who, right? All right. Well, see, these look good to me. I would say. Okay, user process. Yeah, this looks reasonable. So, why are you failing me? Why are you failing? Is object. I'm calling is object on it. So let's assert that JSON is object. I just want to make sure that the first one is an object, because maybe these are failing. This one is failing. Why is it failing? What is it then if it's not an object? Well, I'm confused. All right. I guess we'll just have to print out whatever the JSON type is. Looking very good there. We'll just do that. We'll find out what the type is. Seven. And what, pray tell, is 7? Well, we're not in the kernel, so it's an array. I feel like I'm messing things up with this guy right here. Actually, I probably am, because I'm linking with these classes, and I didn't rebuild everything correctly, so let's just rebuild the libc. Because currently, you get the JSON classes in user space by linking with libc. It's a bit confusing, like where things get linked from. But let's see, application process manager, and let's just clean and rebuild just to make sure that we get everything right. And now if we open the thing, then it looks kind of right, except the physical memory column here is clearly not right. So did we not call that amount physical, amount virtual, amount resident, amount shared? Well, that's interesting, because I guess it's amount resident. It's what that really is. Could that count? Let's see. Region amount resident counts the number of non-null physical pages in that region. So yeah, so that's the amount physical. See, now we're learning that process model, or the process manager, had a different name for that. So this is really like the amount resident. But we can leave it as physical size for now, that's fine. But we should have the right name for the data exchange. Okay, so let's do this and that. Okay, now these things look right. Pretty good. Now we gotta fix this guy up here. So let's see. He is in the window manager CPU monitor. And he's just opening proc all. And what's he doing here? He's reading all the lines and then only looking at the times scheduled. Well, we can still do that better. So that'll just be the same thing that we were doing. And like that. Of course, we'll need the JSON classes. JSON object. And then, let's see, we'll get the process object. Do we need the PID for anything? Yeah, I guess we can get the PID. So the PID is process object dot get PID to debug. And that's process object dot get times scheduled to debug. Wow, look, this code is getting so understandable now. Cool. See if it actually works. Had a spike there. Let's drag a window around a little bit, create some action, and yeah, it actually looks like it's working just right. Very cool. Very, very cool. Okay. Now we just have one thing left, which is the top command, because that doesn't look right. So let's see, top CPP. Here's another one of these sad comma separated value readers. We had so many of these. Let's just go through the motions and replace this one too. JSON object and JSON value. And then we can actually I'm not going to copy paste it, but let's go on top, because we can copy paste some of it. Let's see. So here we open the file. I'm going to go ahead and use libcore C file. I try to use libcore whenever I'm implementing userland stuff. So like in the top program here, I would rather use libcore, because libcore has like C++ classes for stuff like reading files, which are just so much nicer than using the C APIs. So yeah, device read only. If it fails, then return. Can just do that. And that's okay. And then, oh, actually, we should probably bail if this happens. So, proc. Yeah, that's more like it, and then we can get rid of that. Okay. And then we can say, now we can do this stuff from up here actually. So file, read all. And then we get the JSON object. And we get the PID. And the UID. These things should probably share code. It's kind of gross that they're slightly different. Priority. This thing will just happen automatically. And oh right, we have to close the for each member. We'll see how this goes. Okay. Well, we built. Let's see if we can run. And we are running. Looks pretty good. Man, that's kind of cool. That is very cool, actually. So now we're dumping out JSON in the proc file system, and our user space utilities are reading that JSON. Oh, and actually, I wrote a JSON parser offline, so I didn't end up showing that in a video, but it's just a very naive parser right now that it will fail pretty spectacularly on invalid input, but it does work for the output that our Serenity JSON classes produces, which is like the main use case right now. And then, you know, if we need to interact or exchange data with like somebody that we don't control, then we'll have to do a little bit better parsing. But right now it works for this type of thing. So I think that's good enough to commit something. So let's see, what do we have? A whole bunch of stuff. Libgui G-event loop. Oh, that's some unrelated gunk. Okay. Okay, let's just do a patch review. So in the JSON parser, we now this is a bit hokey or a bit ugly here, but we try to convert to a uint before we try to convert to an int. This is just an ugly hack to make sure that we can parse numbers that are bigger than the maximum 32-bit int. And then here was just a thing to get the compiler to stop whining when I was creating it from a size T. And okay, yeah, right now we put larger unsigned ints into special JSON value subtype. I just wonder if did I miss something about that, but I feel like I didn't. Nah, that's probably okay. And then yeah, right, so we're excluding the double support in JSON value if you're doing a kernel build, because we cannot use floating point in the kernel. So that's what most of that is about. We just like hiding or removing the floating point support in the kernel and then adding the unsigned int subtype instead to accommodate larger integer values. That was that thing. I don't even know if that's necessary, but I think it's better to define it this way because this is the thing that the compiler gives us rather than hacking size T definition this way. So we should just go with what the compiler likes. Okay, and then here, this is the process manager data model. We are just parsing the JSON by reading the whole file and then parsing it and then iterating over the JSON objects. turned out pretty cool, I think. Of course, like I was saying, the API is not definitely not final, but we're going to iterate on this. Okay, and here's the kernel code and procfs all implementation where we traverse the entire process table and then create one of these JSON objects for each process and then put those in. See, here we're doing something weird. We're doing git twice. Let's see, git twice. That's silly. Well, nothing too exciting here, but it is neat that we can produce JSON in the kernel because I'm going to want to do this for more things. This is clearly a very handy data format for things like this. And I'm very well aware that the JSON producing classes, like the way that we create objects here, it's definitely not optimal. Like these are like new strings on the heap every time and stuff like that, but that's stuff that we can fix incrementally. We don't have to fix it up front. Okay. I think maybe it would make more sense if this would be an array, actually, now that I think about it, because like it is, we don't care about this thing here anyway. So maybe what we should be returning out is an array. Let's try that. So array, and then we have to really just do it here. Array append, and then all we have to do is append the process object. Okay, and then we have to parse that slightly differently everywhere. So instead it would be as array, and oh, it's an incomplete type, right? So then we need array. And do we have some for each? Yeah, so I can just do that. JSON as object. Oops, oopsie. JSON array. And finally, where is the last one? Process modal. Okay, let's build everything this time. I think it's nicer to use an array for this, just because we don't care about the keys that we had in that thing. But I don't even know, can a JSON object be an array? Is that okay to start a JSON file with just an array? JSON can be either an array or an object. Well, I like what I'm hearing. This sounds like that's okay. I don't need this window anymore, so I'll just close it. And we'll see how this works. Come on, build. Hurry up. I want to test it. Looks good. And good. And what does the proc look like? It's just an array now. Oh, text selection is a little bit flashy, but that doesn't matter. It's not what I'm working on now. Cool. That is very, very cool. So let's commit that. Oh. Kernel. Use change the format of proc all to JSON. Update the process manager top and to handle the new format. Since the kernel is not allowed to use floating point math, now compile out JSON classes without double same or JSON value type. To accommodate larger unsigned ints, added a JSON value. Cool. All right, I think that we're good here. Great. I'm gonna push that and look at the coolness one more time. That is just very neat. All right, so I think that's going to be it for today's video. So if you made it this far, then I thank you for watching and for coming back and hanging out with me while I hack. I think we're doing okay here. Yeah, that's good. Thanks, man, for hanging out. See you later, next time.